I strongly believe in the scientific process. However, science is performed and communicated by humans, and I think there's some room for improvement. Let me paint the picture of the pros and cons of evidence-based fitness as it stands today using my own experience as an example. So this is what I looked like when I think I was around 14 here. It looks like one gust of wind and I'm absolutely done for. And actually, believe it or not, I was doing some resistance training up to this point. But that resistance training was during a very extreme diet, so it wasn't all that effective. I was a bigger kid and then I lost it all very fast and I ended up with the classic skinny fat physique. Whereas this is me a little bit more recently. I've been training consistently for around a decade and I'm not claiming to have an amazing transformation, but perhaps I've graduated out of do you even lift status. But as we'll get to, exercise science has both helped me a ton in some ways, but may have also contributed to some meaningful setbacks. Let's start with the more positive side, how exercise science has helped me, and more generally, what I think exercise science is really good for. So number one, science is the process of getting closer to the truth. And as a result, it helps us understand what to focus on for our strength, physique, or other fitness goals. I'll give a couple examples of how this has helped me. So I remember when I was first getting into lifting, I wanted to buy my first protein powder, as one does, and I researched for weeks, completely confused about the different options, whether I needed whey isolate or if whey concentrate was fine, whether I'd be killing my gains if I had casein instead of whey after a workout. You get the idea, right? There's no shortage of ideas or theoretical physiological rationale for why you need a certain kind of protein at a certain time, but science can inform us what seems to matter most. In this case, a complete protein with all the essential amino acids and a sufficient daily intake, which science also informs us of. Another basic example is rep ranges. Same idea here. You can drive yourself crazy with physiological rationale for why low reps are better or high reps are better for any given outcome. However, science is the process of testing these ideas, and as a result, we better understand the flexibility we have with a variable like this. In this case, we have a good amount of flexibility for hypertrophy, probably somewhere between 4 to 25 reps per set, but less so for strength. Most strength-specific work should be in that probably 1 to 10 rep range for the most part. I could go on with how science tells us what to focus on, and that's why I think it's a little bit strange when there's a new concept with a lot of evidence behind it in the strength or hypertrophy field, and people say that, oh, we knew this all along. I think this is due to the phenomenon of people thinking that something is obvious after a ton of work went into demonstrating that concept in the research, and that concept was previously controversial. So ultimately, I think this leads folks to underappreciate the progress we have made in our field. Okay, our second primary benefit of exercise science is that it is massively helpful for informing how to progress as efficiently as possible. A lot of studies compare two training groups and equate for the total dosage of training. So for example, you might compare range of motion A to range of motion B, and each group uses 10 sets per week. So I view these studies as telling us which group had more efficient gains. Personally, I find this massively helpful. While I do all I can to protect my training time, some days I have as little as 15 minutes to train. I've pieced together multiple areas of research and put together an approach that allows me to still make progress even if I only have a couple hours to train each week. Third, research informs us what levers to pull when progress inevitably stalls. In my view, the role of research is to inform the relationship between a given variable and your outcome of interest. Here's an example from our lab group looking at the relationship between reps in reserve and hypertrophy. The better we understand these relationships, the better we can troubleshoot our training. As another example, it's pretty clear from the research that higher load training is more effective than lower load training for for 1 rep max strength gains. So if you reach a strength plateau and you haven't pulled this lever, so you're not doing at least 1 top set each week on your main lifts, you'll be able to expedite the troubleshooting process because of the data we have. All right, the last one is arguably the most important, and that is that being wrong is part of the scientific process. The scientific process is a never-ending pursuit, and we're always updating our beliefs as new data emerges. Compare this to gym wisdom, which in my experience fails to express sufficient uncertainty and is less likely to update views as time goes on. In other words, our scientific understanding only improves over time. And that seems to me like a really good track to be on. Now, with that said, it isn't all sunshine and rainbows, and as I mentioned, I made some meaningful mistakes that I'm sure have cost me some gains, and I think we as a field can help other lifters avoid similar mistakes. So put simply, I think there is still some room for improvement in a few areas. Number 1 is better accounting for study duration. Now, exercise science isn't a very well-funded field for running studies, and logistical factors such as the length of an academic semester lead to most studies being somewhere in the 8 to 16 week range. I'm not proposing we need to make the average study 6 to 12 months. I know firsthand that that is very unrealistic. However, I do think that this needs to be considered more when communicating research. So because of these short study durations, I view research as a snapshot in time. Now, to be clear, this snapshot in time is incredibly helpful. I'm going to hedge my bets on the better approach, as it's our best approximation for what will maximize gains in, say, 10 years. However, just because protocol A is better than protocol B in an 8 to 16 week study doesn't mean that's exactly how we should apply the findings. For example, a recent study found better results in a group adding sets throughout their program all the way up to 52 sets per week. Now, instead of communicating the findings as 52 sets per week leads to better gains, I'd add some conditions to that, especially the length of the study, and instead focus on the general concept the study sheds light onto, because again, I view research as informing the nature of the relationship between a given variable and a given outcome. And that leads me to the next area for improvement, which is avoiding over-extrapolation. Lifting studies are pretty resource intensive, given researchers are often supervising each training session. Subjects may even drop out because they aren't being paid, and thus resources are lost that you invested into that participant. And ultimately, this means the field generally has low sample sizes and is underpowered. In my view, individual study results are taken to the bank too often. I think a good example of this is the rest period research for hypertrophy. First of all, there's only a handful of studies in this area, and strong claims that long rest periods are required for maximum hypertrophy gains were commonly made. And to be very clear, I made this mistake as well. One study with pretty meaningful outcomes was cited more often than others, making this seem like the case was closed. This was a fantastic study by one of the top labs, but it happened to have more positive effects than other research, which is totally normal in our field. The point is that this study was discussed more, but Zach recently analyzed all of the rest period data that we do have, and there's really no clear benefit to longer rest periods when you look at the literature as a whole. So I think this is a good example of over-extrapolating from little data and potentially taking options off of the table for lifters as a result. And that leads me to the final area for improvement, which is scaling confidence with the level of evidence. I'll use a personal example on this one. I remember being very confused about volume when I got into training. A few years into my training career, evidence-based fitness was starting to gain popularity. That was right around when we had probably the most popular paper in our field published, which reported a linear dose-response relationship between additional volume and additional hypertrophy. I remember this causing me a lot of anxiety about my volume levels. Specifically, I was very worried about dropping my volumes because I thought it would cause me to lose the muscle I already have gained. This is absolutely not even close to the right interpretation of this paper. I was just ignorant, and I by no means blame the scientists or science communicators for my own misunderstanding. But with that said, it might be worth it to pull back a touch on the hype around new findings and make it crystal clear what new findings are not saying to potentially get ahead of these sorts of misunderstandings. All right, that is the video. Thank you for tuning in. Please make sure you're subscribed, and we'll see you in the next one.